Alright folks, today we're going to extend our conversation that we had from last week with equilibrium to look at the equilibrium of acids and in the process determine the strength of those acids. Now before we start talking about acids, let's take a look at a salt. If we add sodium chloride to water, notice we're going to form sodium cation and chloride anion. It ionizes completely. Because it ionizes completely and it's made up of these charged ions, it's able to conduct electricity. Therefore, sodium chloride and other substances that produce ions in water are referred to as electrolytes. Now, notice in my diagram that the bulb is lit up rather brightly. That shows us that sodium chloride is a strong conductor of electricity. Therefore, sodium chloride is defined as a strong electrolyte. Now, hydrochloric acid could also ionize in water. Now, the way this is going to happen, if we add water to hydrochloric acid, immediately H plus will form. Now, this hydrogen ion, also known as a proton, is very unstable. The moment it forms, it's going to react with a water molecule in order to form H3O, which is known as the hydronium cation. Now, if we were to go and pass electricity through it, we would notice that it is a strong conductor of electricity. Because it is a strong conductor of electricity, it's also referred to as a strong electrolyte and therefore a strong acid. Please note that this reaction goes to completion. An equilibrium is not established as when we started off, we had no molecules. When we ended the reaction, we have no molecules remaining, only ions. Now, let's take a look at acetic acid. Now, it can also react with water. And the way it's going to react with water is this hydrogen right here is going to come off. It is the ionizable hydrogen. It's going to produce protons in water. Just like we saw with hydrochloric acid, the moment it forms, it will react with the water molecule in order to form hydronium. Now, if we were to go and place this into a beaker and try to pass electricity through it, notice that the bulb this time is not as brightly lit. The reason for this is that the acetic acid will ionize, but not all that much. Equilibrium very much favors the reverse reaction, which is made up of molecules which do not conduct electricity. Only ionic compounds are going to conduct electricity. Therefore, we're going to find that we're made up of mostly non-conducting molecules. So because acetic acid is a weak electrolyte, because it does not conduct electricity all that well, is further referred to as a weak acid. Now, because acetic acid will form an equilibrium, we can write an equilibrium expression. So why don't you pause the video for a moment and see if you can write the equilibrium expression for this reaction. All right, so we're going to start by writing down our KEQ, and we're going to put down our products, which will be hydronium and acetate, and we're going to have the concentration of them multiplied together, divided by the concentration of the acetic acid. Note that I did not include the water because water is a liquid. We only include substances that are either gases or aqueous. Now, because this is an equilibrium expression specifically for an acid, we instead are going to refer to this from this point forward as a Ka, or the acid dissociation constant. What you see here is a chart of acid dissociation constants for different common acids. Now, just like we saw before when we did equilibrium last week, if the value Ka is equal to 1, then it means that equilibrium will have a similar concentration of products as reactants, but that is an extremely rare event. However, if Ka is smaller than 1, we're going to find that our products will be lower in concentration than the reactants. And if Ka is greater than 1, then we're going to find that the products are going to be greater in concentration than the reactants. So based upon this, what I would like to know is which acid is stronger, hydrochloric acid, this one right here, or the acetic acid we've been talking about. So think about it, pause it, and then come back. Well, the acetic acid is going to be the weaker acid because notice it's going to have a Ka value that's much smaller than 1. Hydrochloric acid would be the stronger acid because has a Ka value that's so large, you just simply put it down as being large. It's so much greater than 1.